So routing oranges, you are given a m cross n grid where each cell can have one of the three values: 0, empty, fresh orange, or a rotten orange. Okay, every minute any fresh orange that is pulled directionally adjacent to a rotten orange becomes rotten every minute. Okay, return the minimum number of minutes that must elapse until no cells have a fresh orange. Okay, if this is impossible, return -1. I think we need to find the minimum amount of time in which all the oranges, if possible, become like rotten. Okay, for adjacent, directionally adjacent. Okay, so we can have more than one rotten oranges in the beginning. I think let's have all the rotten oranges. If we know the location of all the rotten oranges in the beginning, let's say this row, then we can visit the next fresh orange. The distance of the next fresh orange is 1, and from there it is 2, 3, 4. So that means the shortest distance from one of the rotten oranges, but there can be many rotten oranges. Okay, so then the maximum distance, so if there is no fresh orange in the end, and then there will be answer. And what will be that answer? That answer will be the maximum distance of any orange. I think, yeah, it is a BFS. Let's see question 4. Okay, we know the location of all the rotten oranges in the beginning. Okay, oranges rotting. Let's see, oranges rotting. Vector of and grid. Okay, vector of grid. So I think, so first let's create a n is my grid dot size. Is it n cross n or m? We also need m cross n. Okay, we have at least one size should be there. Grid of 0 dot size. Number of rows, number of columns. So n should be greater than equal to n is equal to grid of I length, and okay, at least one row is there. So 0 representing empty cell, fresh orange, and rotten. Let's collect all the rotten oranges in the beginning. So we have the queue of pair of, so all the location of the rotten oranges. So we can traverse over the grid. H less than m. So let's traverse. It's tough to write on doc. Okay, I'll practice. So if that value is 2, that means it is a rotten orange. We can q dot push, we can push that location. This is a rotten orange. Okay, fine. Now once we have all the rotten oranges, now we can apply a BFS, which is, well, q is not empty, empty, well, q is not empty, pop the first one, auto, what is my source node is q dot first, q dot front, remove that, q dot pop, and go to all the directions. So for that I think I would need a direction array which is 4 direction. Okay, 4 directions only. So 1 minus 1 0 0 and dy of 4 is 0 0 1 minus 1. Okay, so go to that, go to all the adjacent, all the neighboring nodes. So from this, okay, you can say key I'm standing at I, which is nothing but u dot first, and j is u dot second. Okay, so that means I need to go to I plus dx of k, this location, and y is nothing but j plus dy of k. I need to go to this location. So when can I go to this location? If and only if x is greater than or equal to 0 and x is less than n, and y is greater than or equal to 0 and y is less than m, and that means I'm inside, as well as I want to visit a rotten orange. No, fresh orange if I need. So from a fresh orange, if I visit a fresh orange, what will happen? Why would you visit a fresh orange from a fresh orange? My queue will always contain rotten orange because the distance will always be smaller. So I have all the rotten oranges. From rotten orange I can go to a rotten orange. So an orange is all. I need to visit the fresh orange only, not the rotten orange. No, because the fresh orange will be the newly rotten orange, not the previously rotten orange. So if that orange is fresh, then only go to that. So that means fresh means 1, as well as the grid of x y is equal to 1, then only go to that. Okay, that will end here, it will end the for loop, it will end the while loop, and it will return the answer. Okay, so if I can visit a, okay, so from the queue I took the first rotten oranges location. From here I'm going to the nearest, the neighboring fresh orange. So if it is a fresh orange, make it as rotten. Okay, make it as rotten. So that means grid of IJ will be 2. So make it as rotten. So from the rotten orange I visited a fresh orange, made it rotten, and put it inside the queue so that it can also rot other oranges, its neighboring oranges. So queue dot push the xy. Okay, I need to find the distance also. Let's have the distance of this new node is nothing but 1 plus distance of my I to j node. It is first time it is visited, and here only we can say the distance of this node is 0. What is distance? It is nothing but a vector of vector distances n and vector of integers of m cross every distance is 0. Okay, I need to find maximum distance, no? So 0 is fine. So all the nodes, okay, so in the queue first put all the roten oranges, make the distances 0, and start visiting all the fresh oranges from those roten oranges. Rot them with the help of this I say xy dx dy. Okay, x less than n, y less than m, grid is 1, so grid ij make it roten so that it's not visited again. Fine, and put inside the queue. Okay, so finally what will be the answer? Now we have all the distance. Okay, so if there is any rotten orange, if there is any fresh orange remaining, then answer is -1. So answer is -1. I less than n, I plus plus. So traverse the grid and check for any rotten orange. So if my grid of ij is 1, that means I can directly return -1. It's not possible. Otherwise, if it is not 1, that means my answer will be max of answer and the distance of this. Okay, so only if it is a else if. So we can have answer if everything is free. If the entire row, entire grid is empty, then answer should be 0, because nothing is required for. So return answer. Otherwise, if the grid is 2, that means we are at, so okay, max of I think this should work, no? Let's see. So first put dx dy. Let's check on the leet code. And then private. Okay. Dx dy. I will check also -1. Okay. No orange is roten. So we have n m and vector distance. Okay. So vector distance, which is n is the row column vector of distance, n vector int m. So grid distance of each node. We take the q, traverse over the grid. If it is a roten, push that. Okay. So if it is a q, roten, push that. Okay, so fine. So if it is a roten, push it. Now second, do the BFS. Well, my queue is not empty. Pop the first one, which node I am standing, and go to the neighboring nodes Okay, x is I plus dx, y is this. Now if that means make it roten, make it vegeted, that means roten, and the distance of this will be okay. So by now we will have the distances calculated for every, so the time to rot every possible orange which can be rotten. So if there is any frizz, then answer should be -1, right? Yeah, -1. Otherwise, let's see. So I, okay, let's see. No typo, please. Wrong answer. Okay, thanks God, at least no typo. Output is -1. Here it is correct. Expected is 4. What's wrong? Okay. What is wrong with this? And for is correct, and then okay. I can't believe this. 1 -1 0 0 0 0 -1 and 1. Okay, n is the grid size, m is the grid 0 size. The distance n vector m, okay, q of the pairs for every 0, you go to for every row column. If it is a 2, that means roten orange, that means push it the location and make the distance, mark the distance as 0. Start from there, q dot front, q dot pop. So if I is u dot first, u dot second, that means we can write q dot front dot first just to remove that. Okay, q dot pop, and for every neighbor we can pole direction adjacent to roten orange becomes roten. So every neighbor I plus dx dy x less than n, y greater than equal to 0, y less than m, and grid of xy is 1. Then make it as 2, that means it is a fresh orange. Because it is empty, why would I want to visit that? Because it cannot rot any other orange if there is a empty cell between. If it is touching that orange, that rotten orange, then only the fresh orange becomes. That's why we need to go to 1 only fresh. If the adjacent is 1 fresh, then only make. Okay, it is not IJ, it is XY. Okay, what the fuck I was doing? XY will be rotting, right? So IJ is already rotten. Q dot push XY, and distance of this will be 1 plus the parent, which is IJ. Then the answer is fine. If there is any remaining, 0n 0m 1 grid IJ is 2. Distance, I think this should work. Let's see. Okay, Yeah, working.